overview of what we're doing for this community. My role is to manage the strategy, priorities of the solutions we develop for this community, and I'm going to spend more time on the numerical modeling aspects of it, since you heard from Dr. Hall on the AI developments. And then my colleague, Dr. Kumar, who's sitting here, is going to come up and talk specifically about one model project we have going with NCAR that's very exciting. So we're going to start with a few achievements in HPC and AI. You've heard a lot about the AI. I'm going to talk about a few things that Dr. Hall did not. I'm going to spend more time on the numerical model developments, and then Dr. Kumar is going to come up and talk about the impasse atmosphere work. Briefly, I wanted to just describe some of the large systems that exist today with the GPUs. You're probably familiar with many of these. I have there are a lot of familiar faces in the room who follow this sort of list. And normally I would like to provide you kind of a roadmap or details on what's coming next for NVIDIA, but we're in a cycle where we won't present this until the supercomputing conference coming in November, so I don't have a lot to share. But I will point out that if you go to the NERSC system that was announced and this Volta Next architecture that's coming, you'd start to learn a little about some of the details behind what we'll be announcing and as far as the performance that could be expected and so forth. But all the systems on the top are already deployed with the current Volta architecture, and then this new NERSC 9 HPC system that was announced will be deployed in 2020. And it's the first system, more or less, that's optimized for both HPC and AI in a single environment. But there's plenty of talks that exist on that if you'd like to go and find those in the literature, and you could learn more about it. Now, one of the more exciting things we did with NERSC, and this was mentioned in the keynote this morning, was the Gordon Bell Award, and that was a team from both NERSC and NVIDIA had worked on this. You'd already heard about this morning. I'm not going to spend time on it. But it was making full utilization of the Summit system, which was also referenced this morning. And we're very excited about this work and continues the partnership we've developed with NERSC and expect to do more of these exciting things in the future. Now at SC18, we also had a keynote from our CEO, and he's even started to recognize this community and mentioned and the number of topics that he had, some of the work that's been going on with some of the numerical weather prediction models. These speed ups that you see here look a bit sensational, but we tend to define a node as 2 CPUs and 4 GPUs. That tends to be what's currently deployed in many of the systems that we see. But the focus is there, and I'm pleased to see the CEO starting to recognize some of the developments. And then most recently, we launched a new NVIDIA AI Technology Center at the University of Reading. This is from the ACES group, people like Brian Lawrence, Julian Kunkel, Chris Maynard, part of this organization. And this is our first AI Technology Center that's focused on a specific domain, in this case, the Earth System Modeling Community. So very excited to see how these developments go. Now I'd like to take some time, though, and it's kind of an introduction overview and go through some of the numerical model developments. And just start with a list I normally show at this workshop that I've been here for the last few years, is kind of the state of collaborations that we have. And these are not the full list of GPU developments that are ongoing in the numerical modeling community. It's more of where we've made investments. And I'd like to point out something I haven't normally, is these are all funded, and we tend to work on projects that are funded through some source where we apply a like investment in these. So some really nice developments are ongoing. I'm going to share a few highlights. And it's a collection of mostly global models and then 2 regional models. I'm going to start with the regional models. And one of the first highlights I'd like to point out is how the Dwarf model is now available, where you could go and download, make a request, and run this yourself. It's a collaboration we have with an organization called TempoQuest. The CEO and some other members of TempoQuest are here today. And they've really developed a full set of physics options that would allow you to run a full model on the GPU. Of each of the options that are available. So if you're interested to test this and see how it might work with your particular configuration, that could be of interest. And in addition to that, NVIDIA had done some other research work on the Dwarf model ourselves, separate from the TempoQuest collaboration. This work, and we call this NV-WRFg for NVIDIA developed WRFg, was some work that was presented at the Dwarf Impasse Joint User Conference, if you were there this summer, where we were able to demonstrate some scaling on the Summit system out to about 512 nodes. What we learned from this research, we're going to bring into the TempoQuest version of the WRF. We see that as really the version of WRF that you would implement for actual production use, and you'll hear more about these projects as they continue. The other regional model I mentioned was COSMO. The interesting development here is that MeteoSwiss, who has developed this model into their operational NWP system, has just brought in the new NVIDIA Volta systems to continue this work that they've been doing. And if you follow their NWP configurations over the years, they finally gotten to a point, both the medium and short range, where they're now fully ensemble based and getting some really nice results. And later they'll go to migration from COSMO to the Icon LAM. That's coming. I see Dr. Schottler from DWD here. There's a joint project going there to make sure that that's ready for GPUs when they go operational sometime in 2022. Very excited about this collaboration. Then later in the workshop, I know there's going to be a focus on 1 kilometer global. This is older work that they did with the COSMO model, but we're able to show some of the challenges and expectations of what will happen when these atmospheric models get to that readiness of 1 kilometer. And they showed some really nice work on the PIS-DAINT system at CSCS of how the sub-kilometer and the kinds of simulation years per day they should expect, the energy cost, computational cost, all these projections are being made. And this work will be very interesting. It was led by Oliver Fuhrer. You may know, I know he's attended this workshop in the past. And I wanted to lead from that into what's happening with the FV3 because Dr. Fuhrer has now joined this Vulcan group based in Seattle, which is a Paul Allen venture into funding climate science. And they're going to look at the FV3 and find ways that they could implement that in a way they did with the COSMO regional model. That is to use this DSL they called GridTools and see if they can get some performance from that model with that approach. Chris Bretherton is also involved, as if you know him from the University of Washington. They're looking at a combined numerical and machine learning model. And Chris Bretherton's leading a lot of the machine learning activities at the University of Washington along with Vulcan, which is based in Seattle as well. And then Ollie is looking at the numerical aspects of FV3. In addition to that, though, NOAA themselves are working on an OpenACC implementation. It's been being led by Chen. He presented these ideas at the Diamond workshop this summer in near Frankfurt during the ISC. And then also Bill Putman from NASA was there. FV3 is used in the NASA GEOS model. They're looking at some other ideas related to COCOS, a sort of DSL approach provided by the DOE. So we have some very nice developments coming with FV3. And one of the ways they got here was to attend one of the NVIDIA hackathons. These are Oak Ridge-sponsored hackathons where NVIDIA and PGI provide people to these to help mentor a group for a week of development. There's been several. This is just what happened in 2019. There was participation from many in the community. And again, I pointed out the FV3, they participated in one that was in Princeton, very local to them, looked at some of the shallow water equation mini-apps, radiation. But this was a way for them to springboard this activity that you saw where they're now moving forward with more development towards FV3 using the OpenACC approach. And a few other interesting developments came out of this community. I'll mention this week, Dave Norton, who's normally here from PGI, is actually at the Met Office where they're having a hackathon around the NemoVar and WaveWatch 3. But there's been a number of developments this year. The MIT CliMA work was kind of referenced in the keynote. I'm going to talk a little about that. You saw this schematic earlier. I won't talk about that, but we're working with this organization. And at the hackathon that was held at MIT, we were able to work on the superparameterization of a LES ocean model that they've deployed. This is the same group that worked on the MIT GCM model. And they've got this now fully running on the GPU and are launching somewhere in the range of thousands of ensembles to achieve this work. It was presented at the Oxford AI workshop that was referenced earlier. You can go and have a look at this work. And I think later we'll hear about it too. There's someone here from this CliMA group who will talk about some of the developments that have been ongoing with Julia. But very exciting to be a part of this trend. couple other quick updates. LFRic, we're making some progress there. There was interesting development from some matrix vector operation kernel that was provided to us by the Met Office, and one of our colleagues, Alan Gray from NVIDIA, had gone through a few steps of optimization you can go and read about. There's a really nice article about it. It not only describes how he got to this improvement, but the different stages in that, and you can look at the actual code and perhaps learn from that if you're interested in how you might apply OpenACC. And our approach here is to help both FTC and the Met Office understand in their approach how to best develop for the current cyclone approach to their model, where they're going to get the most favorable outcome in the OpenACC code that gets generated from cyclone from these optimizations that we developed. A final example would be ECMWF. This is a bit older, but we did some really nice work now that on their weather dwarfs that were around spectral harmonics, and then another advection routine you see here. We started out these optimization states you see at the bottom and got very close to the roofline limitations, and you can see some nice speedups. What's important about this is they're now finally putting these into the model, and they're going to run this on the Summit system. They've got an inside award that has a large allocation, so we're going to start to see how the IFS might perform on GPUs from some of this work that was done in that project. We did some work on single GPU optimization, multi-GPU, so we should be ready to show some results of IFS here very soon. So I'm going to transition now to Dr. Kumar, and we might need some help to bring up his presentation, but we'll take questions at the end here. Can someone please